everyone. You're welcome back from the coffee break. How did it go? Hope you had a good one. Right, so this is going to be the last session for this room. But of course, we're going to have other ongoing sessions in the other rooms, so please feel free to connect. So this session is, we are having two great people coming to share a lot of insight with us. So we've kept the best for the last. That kind of a thing. All right, so I'll just make a quick introduction of the speakers, then I will let you know what they're speaking on. So we've got Amit. Amit is the head of data insight at Access Social Care, with a 20-year career spanning sectors like private industry, NGOs, the UN, and startups. A strategic thinker and data specialist. He focuses on building simple, empowering systems and is passionate about diversity, innovative data solutions. So Hamid will be speaking alongside with Kyle. And Kyle is a software engineer and data nerd. He spent 10 years building a data sharing platform for the institutional fund industry with 2 investment rounds. Inesco founded a startup around a browser-based ETL tool to help democratize data. These days, he works at Flagstone as a senior engineer and helps lead AI efforts. He has a particular interest in improving accuracy of LLMs with RAG. So they will be speaking on a topic title, Adventure in RAG, Are Chocolate-Covered Pickles Delicious? That's an interesting one. Are we ready to find out? So welcome with me these 2 great men. Thank you.
So just to get started, are chocolate-covered pickles delicious? Show of hands. Okay, you're wrong. They're not. They're not delicious. They're gross. And if they're not gross, then effectively we don't have a talk. So, you know. Okay, so you had some introductions, basically table of contents. We're going to briefly discuss, again, what a RAG is. You probably know already, but let's go over it again just to be sure. We're going to talk about our goal with this project, scope limitation, what we did, the problems that we encountered, the solution to the problems that we found, and then the problems with the solution of the problems, and I hope you can see the trend of this ongoing development kind of path. But the reason why we thought that this would be an interesting presentation is because this was a solution that I was developing, and then the software development side is something that perhaps we don't have that much expertise in. That's when I brought Kyle, who was also working on a RAG, and that's when we decided to pool our problems together. And just kind of, if you're starting off with RAG, there's a whole bunch of things that you're going to run into, as you can see, that are not very intuitive, right? This is just kind of our path. These are the problems that we had. I think it's going to be useful for you as well, hopefully. So, what is a RAG? That one, right? No? What about this one, right? Red, amber, green. There was that other talk, RAG. Do you know what this is? This system, red, amber, green system? It's very good for like non-quant kind of things, but no, it's not. It's not that.
So I assume most of us are familiar with LLMs and the process of that whole works. So you can see we've got a whole bunch of information that's gone into the training of this LLM. You might have sources that are encyclopedias or newspaper articles or your Uncle Dave's blog or science fiction or all sorts of different things. Those come together. We train a model based on that. So when we ask a question like, are aliens real? We might have a variety of different sources. And some of those sources we trust very highly. We know they're very high quality. Some of them, real stinkers. So kind of combining all those things together and coming up with an answer that may be something weird. So what can we do instead? We can throw those bits away, use the beautiful language model part of it, but instead of being based on all those disparate sources, we can ingest a series of well-trusted, well-known sources. They might be public sources, they might be private sources, part of our knowledge base or different things. And then when we ask a question like, are aliens real? Hopefully something less stupid. And we have something that we have a bit more trust in the system that we've built. So you all have seen this slide at least 5 times today, but we'll do it real quick for those who haven't had this before. If I can, oh, here we go. We'll start in the bottom left corner. As part of our retrieval-augmented generation, got to get that word in there for RAG, we have our raw data sources, which might have text documents, might be PDFs, might be lots of different sources. The first thing that we need to do is turn them into text so that we can feed it to kind of turn it from human understandable data into machine understandable data. So we're going to extract the text from that. Then what we're going to do is we're going to chunk it, which is just a fancy or not fancy name for breaking it into smaller chunks, usually about a paragraph or several sentences, kind of small bits of fact that when we extract value or kind of assign how these things align, we've got good kind of focused content in small chunks. And then we're going to pass it through that pre-trained model to get our embeddings. And what comes out is what's in fancy terminology a vector. It's just a fancy name for a lot of numbers, a whole series of numbers, which will then feed into a vector database, which is a database designed to hold strings of fancy numbers. And it gives us some extra power. It allows us to compare one vector to another, see how close they are, how far apart they are. We can do math on those things. And it's a real powerful way to look at the data that we've put through the system. So when we ask a question, we literally pass it through the exact same embedding process to get its own vector. So what are kind of the semantic or themes or bits of that? We do the exact same process of turning it into a vector. And then we can ask the vector store, our database, which chunks that we've previously stored match our query. And then just based on those bits of data, those chunks, we can pass those on to the LLM, which does a really great job of synthesizing text nice and readable. But instead of being based on this huge training set or different things or out of date or just the public data, it can give us our correct data in our answers here.
Oh, you need to hold on to that. So the goal, like we said, we both had different applications for the RAGs that we were developing. We're only going to be presenting my use case because it's just much simpler to just talk about one thing. And also mine was better, so but no, let's talk about the RAG that we were working on. So the concept was we were writing a report, right? And the concept is, can we use RAG to help internal staff write a better report faster? There's 3 keywords here. Internal. What does that mean? It's a human-in-the-loop system, right? So that means I don't have to worry about security or redlining or anything like that. I don't necessarily have to worry too much even about hallucination or about any of the other problems with security or productionalizing code or anything like that, because this is always going to be reviewed by an expert staff member, right? So that's a much safer environment. I recommend if you're getting started with RAG to always start with an internal application. The next thing is a better report. This was going to be reviewed by experts. Can this thing search a corpora more effectively than an expert? It's kind of a really, really hard question to ask, right? And faster. So effectively, even if I was to conduct research, how quickly could I parse through 60, 70, 100 documents and then kind of incorporate all of those findings into one report? So that's more or less the objective. I think you can agree that's kind of an ambitious target, right? But the other thing that we were talking about also, this was something that we decided early on, no bells and whistles. We wanted to see what does the most basic POC, what is the simplest that a RAG could look like, evaluate that, identify those problems, document them, and then move on and only add complexity as we needed to.
So as part of that kind of iterative approach where we are just taking as close as we can out of the box solution and kind of poking holes in that, finding problems with that, without a large engineering project, without a lot of resource or be able to do that, what can we do that are kind of simple solutions to solve those problems you might encounter? So we're going no scope creep, not today. So one of those simplifying assumptions is we're not building a chatbot. This is not an interactive experience. We're not doing this at scale, lots of different things. What we're doing is simply assisting in a one-shot kind of report generation step. So we want to do simplicity, just doing answering these questions to allow us to generate text for that. Another kind of simplification is we are only going to process text in this case. We know that there's lots of cool cutting edge ability to do multimodal, lots of cool things and cool research areas about extracting lots of great value out of non-text sources. But for us, we know the corpus is very, very text heavy. We know exactly the documents we want to be looking at, and turns out a lot of it is reports that are text there. So we will only do text.
Thanks. So let's talk about the first solution that we built. Familiarity with Streamlit? Yeah, it's about half of you. That's pretty good. It's a very light Python library. Allows you to develop UIs that look like this, very simply. Highly recommend you try it. So effectively, we just built this app, very, very simple, a store page and a search page. The store page basically just allows us to upload files or specify read web pages, and then basically just grab literally our entire corpora of documents, dump it in there, push digest, and then that's going to do all the process that Kyle was talking about, the chunking, the vectorizing, the what have you. And then on the other side, we have a search page that literally is nothing more than a text box and a button to activate. It's very, very simple, right? This is literally all it takes, a couple lines of code. Okay, so we're going to talk about code just a little bit. Familiarity with Python language, okay? People that are not familiar with Python? All right, well, there you go. I'll bring up all of this in case you guys want to take a screenshot. I'm not going to talk about too much. I'm just going to pull up the fact that we used the recursive character text splitter from the LangChain library. And the good thing about this is it just kind of does a bunch of that heavy work for you. We decided to go for a chunk size of about 1,024 tokens, so about 1,000 words, more or less. We decided a small chunk overlap of 32, but a non-zero chunk overlap. That's important. We'll discuss that later as well. An important limitation is that this recursive character text splitter doesn't have any metadata with it. This is kind of a big deal because I didn't want it to just take chunks and give me text. I want to know where it came from so that I can, first of all, verify that this is actually true, and second of all, to ensure that it's balanced, all that stuff. So I had to write this stupid thing here to force metadata into a document configuration. And you can see that metadata down here. See how it says here source, blah, 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 and then chunk 4? So that's just that is the perhaps, you can already start seeing how you have to start adding some things. So already just the out-of-the-box recursive character text splitter, it didn't do what it needed to do. But again, very light modification here for the metadata. In terms of the embedding function, we decided to use this all-mini LM L6 V2. It has a really good trade-off of accuracy and latency. It's pretty fast, and it does a pretty good job, and I recommend you start there as well. In terms of the actual vector database, we decided to go with Feis. It's a Facebook product for no other reason than because it allowed for very, very simple local storage. And considering this isn't running on some big VM or anything like that, this is just running on a computer, and we didn't have to redigest the entire corpora every single time. I wanted local persistence, so that's why we decided to do that. Nothing really more to talk about here. Just a couple of things. So this was the prompt that we used. Important things here. I'm not going to, you can read it all if you want, but I'm just going to call out. I'm telling it that it's a RAG. I'm telling it where it can find the metadata for each chunk. I'm giving it an objective, highlight inconsistencies between the sources. So I'm telling it what I'm feeding it. I'm telling it what I expect from it. Very important when you're speaking to an LLM to be explicit about your intentionality. I also wanted to know whether it was going to give me a bullcrap answer. So that helped with that. I also wanted it to start quoting sources. You can start seeing how the prompt engineering and iteration comes by. I would do the thing, and yes, it would give me the sources, but it would give me the sources embedded in the document or all at the bottom in endnotes or whatever, and it was inconvenient. So you have to go in there and specify, this is how I want you to treat me. And then this one's a fun one. Write in British English. Nothing is a telltale sign that somebody used an LLM, like using American pronunciation in a British report. Not that I did that. This happened to a friend of mine. It did not happen to me at all. But yeah, and also important, not only just the pronunciation, but also tone. Taking into consideration, don't write for Americans, right? Very big deal. In terms of the actual process of making this happening, this was something that was perhaps a little bit, this was one of the things now that it was like, how do you actually make all these things work together? So we're going to walk through this process a little bit more slowly. Search query comes in. What does the search query do? We pass that through the similarity search with relevance scores. Importantly, notice that you don't have to actually vectorize the prompt, the search query that comes in. That function does it for you. So that's kind of cool, right? That's pretty convenient. So we take that search query. That is going to look at our vector store and return to you this number of chunks. In this case, we asked for 10 chunks. Okay? So this results has given me the 10 most relevant chunks for my question. We are combining these results with the prompt into what we're calling here the full prompt. It's here. So basically, the top semantic search results are that, in addition to the prompt, which is what you had seen earlier. So now you have the instructions, and you have the chunks. We combine that with the search query into input text right here, and this input text is what's being passed to the, what we're going to call the generation phase, the generator model. What was the generator model? It was just GPT-4. And the instructions that you have to provide at this level are actually quite simple. You are a RAG retrieval assistant. That's it. That is all it needs to know what it's supposed to do. It understands the kind of inputs that it's receiving. It understands that it's got a search query in it. It's got its chunks. It knows what it's supposed to do. We're off to the races. It looks like this at the very end. So you can see this is the actual natural language generation. We don't have to read it, but basically this is an answer to a question. You can see at the bottom, it is actually specifying the source with the chunk. This is very, very key because at the very beginning when you do this, you want to make sure that it's not lying, right? So something like this allows you to go, verify, make sure that this is exactly the way that it's supposed to be, and then you can process that document however you need to. At this point, we're going to stop with that and just mention that the chunk selection is being done by semantic similarity only, right? Keep that in mind. Given a question, I'm matching based on semantic similarity, and I'm using that to select from, I think we had 4,000 or 5,000 chunks, right? What could go wrong?
So what did we have after we had built that? Problems. So we're going to enumerate them and talk about our strategies to mitigating these. So number one, plagiarism. Turns out when you are trying to write these reports and generate content as a synthesis of lots of things, by default, it's kind of like a fresh schoolboy. Likes to liberally take from documents and put them in others. So what do? We apply a little bit of prompt engineering. We say, don't copy the text verbatim. That's plagiarism. So don't take sentences directly from the source material and put them in the output report. But let's go ahead and paraphrase a bit. So how do we do? Solved. Excellent. What about next? Source selection. We have this, as we just mentioned, this problem where when you are passing content onto the LLM phase, only what you pass it is going to be part of the answer. That's a very intuitive thing when you think about it. But that means that when particular chunks or particular documents might address the question exactly most semantically, if it's just one document or it's just one source, we're going to get answers heavily based on just that, because that's all we're passing on is those highest relevant chunks. So if we have 180 government sources that talk about this issue, you can imagine a lot of them probably hit those keywords and those concepts pretty well there. We have 3 key charity reports that speak from a different perspective. We're going to lose that signal in the noise, and all the chunks come from the central government. So have we solved that problem? Not quite. All right. We also have the issue of perspective. So we ask a question of, it's very important when we're synthesizing these different perspectives on an issue. What does the King's Fund think about social care at the moment? So if we look at the result, the chunks we get, not so useful, right? We can see that our top result gratefully does come from the King's Fund, but a lot of different perspectives on this. So the problem you can see is if our whole chunk comes from this, but we only have this little tiny bit of data about where that actually comes from, it doesn't really understand it. We haven't provided enough context to the LLM to understand how to answer this question well. So yep, we can do a little bit of prompt engineering to attempt to fix it. And so let's look at the source property, but what does that do for us? Unfortunately, so I don't want to block it, doesn't solve our problem entirely. We're still having some issues there. So another issue that we encountered is when we're lifting bits from here and there, we're getting those pretty literal, right? So it might be, we've received complaints, or there are complaints, or different bits there. We know that the LLM has trouble with that. So if we can do our classic, reach for our classic tool here, and say, just do a little bit of prompt engineering to allow it to say, it's important that you restate that as yourself and don't take those things liberally. So we also have the problem of context. This is, again, a theme that we'll see throughout this a lot, in that you can imagine that if you just, even as a human, are taking bits of this, this paper and cutting off little chunks and handing it to someone, if you happen to choose a chunk that doesn't say, don't do this ever, and just have instructions in there, you can imagine the answers that come out not of the highest quality. So we talked a little bit about chunking before and that strategy, and you can see where we have a little bit of overlap between these. So we start taking some tokens from the previous, and the following one, and then combine those into our existing chunks, and that gives us more context. So that is a better area. But there's balance there in that, you remember that problem from before where we were getting chunks just from one source? As soon as we start loading up all these chunks with all this context, our search results are just going to be from those single documents or single sources. So we have to like strike the balance here between providing more context in that sense, as well as making sure we're seeing disparate sources. So in this case, overlap helps, but doesn't eliminate the problem.
We also had a little bit of hallucinations. What hallucinations? I thought you were using a rag. It's not supposed to hallucinate. You're using AI, it's going to hallucinate, okay? It's not facty, it's hallucinate-y. That's all it ever does. It's just some hallucinations are more useful than others. In terms of this, we did only have 2 instances of hallucination. I don't remember how many questions we asked. I said 100. It was 100, 200, whatever. The point was, it was very few. So if we wanted to, we could have modified the temperature. At the beginning, you remember, we had a non-zero temperature. So we could have done that to try to modify it. However, at this point, and considering that this is a human-in-the-loop system, I can live with that. Because when it does hallucinate, it was very clearly hallucinating. So it's very easy for experts to look at this and say, this is very wrong, right? So I also want to bring up that some problems you don't have to solve, right? And that is what having an internal audience first gives you. It gives you that flexibility to choose to say, I'm not going to fix this because I like the way that the system is working for the rest of it, right? What it did highlight is the fact that we should log more. So it was around this time that we started realizing that eval is not really something that you can do retroactively. We really should have done a little bit more thinking about how we're going to be doing the evaluation ahead of time, but that's going to come later. This was maybe one of my favorite problems. Recency versus accuracy. And again, by accuracy, I mean semantic relevance, perhaps. Look at these 2 chunks, okay? One of them comes from 2019, one of them comes from 2022. The accuracy or the matchiness of this first chunk is higher than this one. So when I ask a system to select between these 2 chunks, it's going to pick that one, right? Because it matches the query better. But it doesn't understand that this is old. So if I feed this into the generation phase, it's going to assume that the truth is what that other chunk was, just because the accuracy of this other one happens to be a little bit lower. But any human would look at this and say, don't use an old report when you have a newer report available to you. But that's one of the problems, that having a chunk that only looks at semantic similarity, it misses that. More importantly, and interestingly, imagine you have 5 chunks here, okay? These 4 are from 2022, and this one's 2019, right? If I say pick 4 chunks from here, it's going to pick those 4 chunks. So the generation phase is going to have no choice than to say, XXX is a green, transparent ball and has gone down. How could it not, right? If the only place that it understands time is by reading text, and that happens to not correspond to the question, it's not going to pick the chunk. If it doesn't pick the chunk, the generation phase doesn't see it at all. This is a really interesting problem, and we did not solve it. And then finally, we get to the eponymous, that one, you know which one I'm talking about. Chocolate and pickles, right? So you have one chunk is a central government source, and it says, there's no problems here. Everything is fine with social care. And you have another one that comes from a charity, and it says, there are massive problems. Literally look anywhere. You're going to come up with text that says this. There are no problems with social care. The first of the many problems are, which makes the report look a little bit funny and makes people say, is this rag working the way that it's supposed to? And it's like, well, I mean, The problem is then, interesting, we tried to formalize what the problem statement is. There is an inherent perspective with sources. We have 2 options. We can either try to encode that, so to say, when you are reading a document from central government, assume that the central government's agenda is blah, 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 right? And we could go through and actually map that out for everyone. There's a couple of problems with that. First of all, I'm introducing massive bias. You see the amount of bias that I'm introducing here. And second of all, you know, if I'm fixed in my view of what each report is actually saying, you know, can I actually change? Can people change? Can the reports actually modify that perspective? So we decided to not do that. and see what other options we can do to try to solve this problem. But yeah, inherent perspective, kind of interesting and unsolved as of right now. If we can try to summarize our problems, let's try to come up with a better way of looking at this. Let's build a RAG to measure our RAG. See what I'm, red, amber, green? Get it? No. Yeah. So basically, let's just look at these problems. So you can see that we solved 2 problems, 4 problems unresolved, and the 4 problems that are bad, that are unresolved, that actually limit the utility of the system, and then 4 other ones that are kind of solved. It's uncomfortable, it's not great, but yeah, so that's more or less where we are.
So what do? Even more solutioner. Next generation. Our answer? Metadata, metadata, metadata. One guy in the back, thank you. All right, so we thank you for that as well. We decided to be able to try Chromatic and use ChromaDB is a vector store that gives a lot more prominence to metadata, allows us to directly query that. And by kind of combining a better engineered data model about how we store our metadata, as well as giving support in the application, and a little bit of fudging in explicit querying gives us some pretty cool things. So here's the overview of what it's like. We chose Python as our language. As you know, we're building a Streamlit here. It's got support for lots of different languages. It supports vector store, full text search, document storage, metadata filtering, great theme there, as well as some multimodal stuff that we're very excited about, but not quite experimenting with yet. It's Apache 2. Everyone's got to love open source and supports all your favorite models. So here we go. What does the interface look like now? We have the ability to, again, still upload documents, but add a publish date and the source of the document. We did a little bit of experiments with maybe we could generate that from the LLM itself and come up with that. But for now, it's an explicit kind of field. But just capturing, we know we have that metadata. We know it's correct. So let's input that here. And then we ask our question, but we can do a little cheeky filtering here. So now when we know that we have kind of undersampling from certain sources, we want to incorporate other voices or ask what is a particular voice on a matter, we can do that at a very top level and know that those chunks will not come from the database. We very explicitly can sample where we need to sample in this question. So a little bit of hard coding gives us a lot of power in the kinds of questions that we can answer. So what does it look like in practice? Our metadata. You can see that now we have the text here, and at a very high level, we make very explicit not only the file name, but the name of the report, when it was published, the publisher type, and the source type. And that gives us a lot of power in changing how the answers come out, in kind of bringing that from just a small little string that says, here's the file name, to making that at a very, very high level. Turns out, yes, and we can also explicitly have queries that pull out that source when we're looking at that undersampling problem that we had, that we can pull in those explicit bits. So, hey, we can now pull out those explicit bits in query and have a good time. Yeah.
So what does this do for the recency solution? Let's take a look, right? The question, what % of their total budgets are council spending on social care? And I specifically limited this to a document type that I knew had very limited things. So I knew exactly what I was looking for. And importantly, you can start seeing how it starts pulling out these dates. And it arranges them more or less in order, not necessarily perfectly in order, but it does seem to have detangled the problem that it had originally, which is that it's combining everything, it has no idea what time is. Now it understands what time is at least, right? So that's kind of a big deal. And it also does, in other experiments, it does show that not only does it understand the fact that time periods is something that exists, it also does understand the sequential nature of it. This example doesn't show it very well, but yeah, I do think that these 2 problems were solved. We were curious about, does it actually understand this latest data though? Right? So does it understand? So it understands the sequentiality of time, but does it understand what latest means? And in this case, yes, it does. It does reference some other years here, but it did conclude with the latest one. So that's good. We did fix time. However, due to the lack of explicit numbers in the provided sources for the latest years, I have a medium level of confidence. No, it does have numbers in the latest one. So we fixed time, but we broke the functionality of the damn thing in terms of trying to actually being factual about stuff. So yeah, that's not great. Something else that was interesting while we were debugging this, we had a debate about whether it was inferring the concept of time or whether it was actually reading it from metadata. And the reason why this matters is because, again, at the UI level, we want to be able to control what chunks it picks. So did it actually understand this? And in fact, you can see here we used a fake publish state, and that was reflected in the chunk. So it does actually pull from the metadata, so that was very good news. What does this allow for? I mean, even right here, this was where it blew my mind, and I actually had to pull my CTO in and show him this. It allows me to construct a question, how's social care doing, and ask that from central government sources, and do the same thing and ask charities. Do you realize what a powerful policy tool this is to try to digest a series of documents and ask what is the perspective by this group, compare and contrast? We could build a RAG after this that takes these two, points out the differences, and tries to make assumptions about the policy thing. I mean, we could use this for a bunch of things, right? And you can see that already this toy example is super useful. So this is incredible functionality, really quite good. All the sources are the same. So remember when I said that I was limiting that corpus to a small limited thing? I didn't know that it was going to pick so severely that it was going to pick from only one source and ignore everything else. So again, this is not what I wanted. That's not what I was saying. Kyle, you do it. I can't do it.
So now I present to you our solution to the problems introduced by the solution to our problems. All right, so you can see we go to our old classic favorite, which is prompt engineering. Whenever we enter a problem, first thing, simplest problem, right? We just go to the simple solution of don't reuse chunks from the source. There we go, even if it means using fewer chunks. Also, look at the publish field to make sure we emphasize those recent results when possible. Let's ask the question again. And hey, we get a nice variety of sources where we're looking and we're sampling and we're doing lots of different cool things there. All right, you too.
So running out of time a little bit here, so let's just look at, in terms of the modification, the difference from where we were before to afterwards. You can see that we're mostly green, right? So we haven't solved all the problems, and in fact, we had a non-problem that we converted into a problem. Welcome to design kind of a thing. But you can very clearly see if you analyze the RAG of our RAG. You can see that we were at 2, we were at 7 green. I think this is enough. The main question was this enough for us to be able to accomplish our objective? And yes, this was enough for an expert to review these sources and be able to pick more thoroughly from chunks and to do it faster than if we had to do it ourselves. So already this toy example was mission accomplished, not like George Bush.
Just the one. All right.
Yeah.
All right, what did we learn? Even a simple RAG, just applying a little bit of prompt engineering, a little bit of metadata, a little bit of UI here, we can take something that's pretty much out of the box and create a very powerful tool where it is able to synthesize documents and create this kind of wide view of a huge number of different sources and really provide a policy tool that's very, very powerful to put in the hands of people. We know that there are some details where it's not quite right yet. We wouldn't trust this to directly publish. We're not going to have the go on vacation button for the annual report. There is going to be some involvement with human factors, checking these facts, making sure we're doing it, but we know it still is a powerful tool. We know metadata isn't optional. We have to treat it as a first-class citizen. We got much more accurate answers. It had a much better understanding of how things changed over time, about how different sources felt about things, about different things. We had to treat that metadata and put that in a prime spot there to be able to get good answers. And also, we probably should do a better job of creating a matrix of evaluation criteria, how we log it, how we keep track of our parameters, our input documents, and the responses that come through, because sometimes we got some regressions. So it's good to have the ability to evaluate how we're doing.
So future considerations, the main thing to try is chunk re-ranking. So what we can do is increase the number of chunks that we retrieve and then implement an actual intentional program through which we subselect just a small portion of those chunks that we can apply a little bit of BI to that as well. So that could provide some value. Llama Index integrates very nicely with ChromaDB. And what that allows us to do is smart chunking. So that problem that Kyle was talking about where, for example, it doesn't know the title that it comes from, that comes right out of the box with Llama Index. That's quite cool. Of course, multimodal. It's not like a full crazy thing, but it starts going down that direction. Knowledge graph, I'm very, very passionate about knowledge graphs. And as you may have seen the Neo4j presentation, they have their whole own kind of universe. Yeah, ask me later about how well it's doing. But yes, basically that's the kind of things that we want to try. But importantly, see that scope creep that was banned? Yes, we can try it all now, no deadlines. And yeah, and just question mark, like what else should we try? If anyone has any suggestions for what else to add. I'm not done yet. So now we're done. If you scan this, you can go to our LinkedIn. And also, I'm a charity, and we just want a major freedom of information request against the government. And we need money to fight them a little bit more for justice for everybody. So if you can, visit that and see what you can do about that. Thank you very much. Questions?
Hi. It's super exciting. Thank you very much for that. What is your retrieval algorithm at the moment? Is it just like parent document, or is it text-based? Like, how do you retrieve your text?
Yeah. So we just we vectorized the query, and just basically that's the beautiful part of ChromaDB or lots of other options around that. It's each chunk has a vector, and we match that against the query vector. And whatever's most similar, here we go, comes out of the database.
So your first enhancement, I think, will be there. In that sounds too straightforward to me.
Yeah, there's there's an area of opportunity, and specifically around we have enrichment and different database products that have better opportunities for. I think actually there's really good opportunities around how we compare. Even vectorizing metadata in its entirety and comparing those things, where you can create kind of in-database comparisons and create similarities which are mixing in different sources according to if we want to weight things from particular sources or different ways, and that we know there's very nice mathematical ways to start incorporating a richer model around that. But yeah, the goal of this mission was what can you do with out of the box as close together, a little prompt engineering and do that. And yeah, I think we're very happy with the result.
Cool.
Two questions. One is, what are your evaluation plans? Do you have any list of steps or frameworks that you want to use to start evaluating what you've just generated, or is still plans to do? The second question is, have you considered running your prompts through something like Anthropic's Claude prompt enhancer? Because you can actually find gaps and holes in the prompts and improve the prompts so that human-written prompts are going to be as good as us, right? I mean, you can find other aspects to it.
Yeah, that's great. I think in terms of the eval, and considering the kind of bootstrapped nature of this presentation, quite honestly, step one, just output what the prompt was, what the chunks were, and what the answer was, right? So just so you can at least revisit this and do the same experiment later and see how the values changed. Outside of that, there are a variety of frameworks. We haven't tried enough to give any specific recommendations for any one framework, but there are a bunch, and they do integrate very well with ChromaDB.
But I think that's one of the things that I bring a little, like the software side of it, and you bring definitely expertise in the domain and lots of things and how we evaluate this. But that's for me, it's like the concept of a regression, or how we know that we have weaknesses in certain areas, being able to track those things over time and against certain criteria. I think that's a great way to do that, is know that we have problems, we've encountered problems, we know what we're expecting, or maybe we don't, but as soon as we encounter a problem, we're able to then evaluate any solution against those things.
Yeah.
So yeah, no, I think it's a very good point and something we'd love to explore.
Yeah, and I think, the formalization of the prompt, by asking an AI to do that, I think that's a good idea. I think for the whole fun part of this process was, how far can we modify the prompt in order to actually change the functionality of this RAG? And as I hope we proved, you can massively change this, right? So it is extremely susceptible to that prompt. So outside of the metadata being promoted to a first-class citizen, I think just ensuring that prompt is as good as it can be. I think that's the next thing.
I think I've seen a lot of that do's and don'ts. When you specify that it becomes more disciplined.
Yeah.
I think every time you said, oh, this is a problem and I broke that, it's just simply because you enhanced one statement more than the other, but you didn't put a balance to it by saying do this but don't do this.
Yeah, thank you.
Keep guardrails.
Yeah, thank you. Take a look at that. Thanks.
Hello. Thank you for your work there. It's very interesting. Nice to see that you've developed a schema of metrics for your RAG. I was interested by the remark that you made about you only detected 2 hallucinations. And from what you said earlier in the presentation, I understood that you'd evaluated your work using sort of fingertip reading by a subject matter expert, right? So I was intrigued to know whether you used any sort of computational tools or metrics that were outside of that to evaluate yourself or score sort of like a word counting or something like that to review it and score yourself as well. And the question, I guess, behind the question is, have you considered doing any of this sort of red team approach where you have another AI marking your work for you?
Yeah, I think the main concern here that I had was I needed to make sure that the legal experts, I work for a charity that has about half of the charity is lawyers, so I had a very short leash, as you can imagine. But the main thing, what this RAG was supposed to be doing was effectively, instead of having someone parse through all these reports, to just say, it's these 3 things. But it was so easy for them to look and say, no, I know that source never said something like that, so I know that this is wrong, right? And when it was right, it's like, yes, I know that they did say this. It's just, did they say this in this year, in this report, or in that one? So that's the bit that was saved, right? And to make sure that the tone of the chunks was consistent with our charity. So that's perhaps more important. The whole thing of red teaming, I think, if we were going to put something like this external, everything changes, right? Like, for example, I wouldn't put a delete the entire store button on the UI. Also, I wouldn't allow just anybody to upload documents, right? Because they're going to upload whatever they want in an untrusted way. So it was a very, very contrived example, but yeah, absolutely, that's the kind of stuff that we would have to consider before going to production.
Or even opportunities for improvement. I think that how we evaluate and incorporate changes to that. There's an infinite kind of range of possibilities, and this was certainly an exercise in kind of ChatGPT can do a certain thing. We know it has failings, but if we start to tweak a particular thing, but certainly new avenues.
Yeah, and I think the important thing also as well with that, when we took that slide out just because of time, but it's important when you're doing something like this, right? All of us technical people, we jump immediately to the optimization phase, right? So say, GPT-4 isn't giving me the thing. Oh, let me try Anthropic. Let me try Anthropic 3.5 now. Let me try this. Oh, no, that's not working. I'm going to go to Claude. And a little bit like, shut up. Like see how far you can ride any one thing, right? LangChain, we had major problems with dependencies and stuff like that. It's horrible software from dependency. But it's wonderful software to evaluate the concept. See what I'm getting at here? To say we've took that stupid prompt so much further than we did at the very beginning. And the reason why is because we only went to increased tech when we absolutely needed to. When we realized that the metadata, my little stupid attempt to convert everything to a document and to put it in, it was woefully inadequate. So you have to. You don't have a choice to upload the technology. But in terms of things like this, or frameworks, or switching frameworks, or all these kinds of things, you may or may not squeeze performance out of it, but you have intrinsically misunderstood what this software allows a human to do. Does that make any sense?
Hi, thank you very much for your very entertaining and informative presentation. I have a question, actually two. One is a suggestion, one is a question. The question is, during the phase of similarity search, which algorithm do you use to retrieve the distance? Is it Euclidean distance, cosine similarity, these kind of things? And can this address the issue of re-ranking the chunks so you get probably different results? And the actual suggestion instead is, instead of optimizing the prompt, which we've just discussed in a way, have you tried to fine-tune the model on your expectations? Like you take, I don't know, Llama, Gem, and you just have set answers and questions. Thank you.
Yeah,
that's it.
I think fine-tuning is a very, very powerful technique. I'm sure a lot of us have experienced for problems. That's how much of a difference that can truly make. I think in this particular case, it is kind of the premise of this project was how do we create something that kind of as non-technical people can interact with an AI system and how to improve it, like as an exercise kind of in that way, as opposed to, there's so many really cool ways, and I'm actually very interested in how we start driving the query and chunk searching process in a much better way. But that's unfortunately out of scope for what we're doing. I think that there's so much left on the table to do really cool things, and fine-tuning models is one of those things.
I would also advise you not to go to fine-tuning. It is much more complicated than it looks to get a good result. You can get much further by indeed going to opting for a new model, right? And in addition to that, then that gets you more stuff in terms of red teaming, safety, security, all of that stuff. So.
And there's always the challenge in which we do things and invest engineering resource into a project, and the state of the art has moved so far by the time we finish those things.
That's exactly it.
It's always a balance. So I think it's always fun to explore those possibilities, and there's really cool use cases. We know people doing incredible things, and have seen, I hope it's some of us very personally very cool things with that. But it's an interesting problem that will continue to evolve.
Yeah, and in terms of what algorithm that uses, I don't know. I think it's cosine similarity. I think so.
Cosine.
But yeah, I mean, you can look up that's the function, so just look it up.
Yeah.
No worries.
All right, last question.
Can you hear me?
Yes.
Oh, great. I found out one of the problems that you had whilst I was listening was context relevance, and I've actually had a lot of experience. Well, last 3-4 months, I've just primarily been working on RAG systems. And one thing I found was one of the best ways to improve context relevance would be using hybrid search. I don't know if you've tried that before. Hybrid search. Essentially, what you do is
hybrid search.
Yeah. Essentially, what you do is you use a keyword search along with a semantics search, and then you kind of combine both approaches, and then you do like a re-ranking. And I found that was like the best way, rather than even using optimizing your prompt. So I don't know. I just wanted to check if that's something you definitely tried. But if not, and also another thing I tried that worked quite well was indexing the documents and using metadata, like you just mentioned. And when you do like a query routing, it kind of like segments and windows down or chunks down what is relevant to the query. So I don't know. I just thought something I just put out there.
So I've done hybrid search stuff. My use case was really ingesting policy documents for a particular thing.
Okay.
And what I found is quite often the keywords would overlap significantly between things. So we'd be addressing the same things without finding kind of the heart of what we need is actual factual information behind it, where you might say like, proof of address or some concept that you find in lots of different places that doesn't drive to, well, what actually is the requirement about that? Well, just because you mentioned something in that thing. And so I think there are many use cases where hybrid search works exceptionally well, where we've got very disparate concepts, lots of different things where we could find, it's not just a distance vector of like how this concept relates to one, but actually that word itself is important. So I think for some use cases, that's absolutely critical. Sorry, I've forgotten the rest of the question.
Well, he was talking about the document chunking.
Chunking, actually,
method,
the Llama index actually excites me a lot, particularly for this project, is being able to enrich that chunk. It feels so naive in how we do it. We talk about like section headers of documents, right? That's quite a big thing. Is that to me where we can bring the richer metadata around what this document actually represents. Probably in most cases is almost as important as the content of the chunk itself. And I feel like in a lot of ways we don't yet bring that context in enough, and that's where I think even it's a hard problem because these documents are built for humans, but the kind of cutting edge in that regard and how we enrich the metadata around the chunks themselves, I think is going to be one of the most powerful things for this, for sure. So I'm very excited about that. Yeah. And we've done some experiments in even just like asking, like, look at this document, you tell me, right? Like, have it in a kind of autonomous way, try to come up with those things. But it's not a problem that's tough. It's not an easy nut to crack, I think.
And one last thing in regards to evaluation, I think one of the things I used that worked quite well was LangFuse. I don't know if you've ever had the chance.
LangFuse has a dependency problem with freaking LangChain. So yes, I tried. No, I couldn't. But yeah, no, LangFuse
Thank you for
is
your
awesome.
question.
It's going to be on record now.
LangChain sucks. No. No, it does not suck. LangChain is really, really powerful, and it is
I don't like it.
the issue with LangChain is that it is an opinionated universe, right? But it's got GraphChain, it's got like a whole bunch of stuff that's designed to work together. It just doesn't play well with anything else. That's just the only problem.
Yeah. You have to use
But-
within the same ecosystem.
No, LangChain is awesome, okay?
Thank
I
you.
talk a lot of bad things about LangChain. LangChain is very awesome, and you should start trying there.
On a scale, yeah, but if you're working on POC, then
Oh, I'm sorry, Mr. Fancy Guy, then whatever, when you build a freaking thing in your presentation.
Amazing. Thank you so much.